trinomial, which is how many terms? 3. In the form a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. And it's the result, or I guess we could say maybe the product. The result of squaring a binomial. So what this means, actually I'll wait until you write that down. So just so we understand, the first and last terms are perfect squares. And then that middle term, 2ab, means that it's twice the product of the first and last term. Well, twice the product of the square roots of the first and last term. I should say that. Okay. Let's just talk about what a perfect square is. Could you please, if you're not sure, that's okay, but please talk to the person closest to you. What in the world is a perfect square? Okay, could someone, maybe we could do some examples of perfect squares? Micah, you got an example?
No, but
Okay. Bella, what's an example of a perfect square?
Would it be like 4 by 4?
Uh-huh. 4 by 4. So the area would be 16. Ben?
It could be 6 by 6.
6 by 6, so the area would be 36. 36 is a perfect square. Maybe you're catching on. To some examples of these. So the first term here is a 1. The last term is a 16. Both of those are perfect squares. The middle term is the square root of those things, and then times 2. So this would come out to be, I don't even have to use, I can use the method that we've been using, but I know that this has to be h plus 4 times h plus 4. Two of the same binomials multiplied together. Luke, what's a better way to write that?
H plus 4 squared.
Yeah. So this is what you just saw. That is a perfect square trinomial because the first and last terms are perfect squares. That middle term is 2 times 1 times 4, the square roots of those numbers. Okay, look at this one. Is that a perfect square trinomial? Yes, first and last terms, 181. Those are both perfect squares. The square root of 1 is 1. The square root of 81 is 9. 2 times 1 times 9 is 18. Good. So this is going to be something squared. What would it be? Could someone tell me, please? Sathvik, what's it going to be? N plus 9 squared. You could do it the same way we've been doing it. Two numbers that multiply to 81, add to 18, you get the same thing. Now, this is where it gets helpful, okay? Because this would be a really large number if you multiplied a times c, but we don't have to do that because what do you notice looking at the a and c? Tell the person closest to you what you notice. Okay, Julian, what do you notice? Yeah, they're perfect squares. Term should be 2 times the square root of 64 is 8, times the square root of 49 is 7. So that's 56 times 2, 112. Good, this is a perfect square trinomial, so you get to take the shortcut. I'm going to write this down and see if this makes sense to you. The answer to this is 8x plus 7 squared. Why does that make sense? Could someone please explain where that comes from? Bella, where's that come from?
Well,
Hold on.
you said that, they're 8.
Okay, difference of two squares. So that was perfect square trinomials. Cool. Moving on. Difference of two squares is when we have something like this. A squared minus b squared. And this is always going to turn out to be a plus b, a minus b. Because, I'm going to write a little explanation here because I know for a lot of us that's helpful. Because b is 0. Again, you could do all of these with AC grouping, but like the one you just saw, that would be pretty awful. But this works because b is 0 and you need two numbers that add to c. You've done some like this before. If you want to do this the way we've been doing it, that's okay, but I'm going to show you the way to do it quickly. I'm looking at this. This is in the form w squared minus 144. It's in the form a squared minus b squared. My c is negative 144. My b is 0. The a term is 1. But look at it a little bit closer. What do you notice about the numbers in front here? Luke, what do you notice?
Wait, shouldn't it be a squared minus c squared? Because the b value is 0.
Yeah, I guess, yeah, let's change it. I mean, this is typically, I guess.
Because we
Yeah,
we talked
I
about
suppose.
the b value. Then they say b is 0. So
Typically, I think, as long as you understand. Yes, thank you. Since the b is 0, there we go, and you need two numbers that add to c. So looking at w squared minus 144, the number in front of w squared is 1, and then 144, is that a perfect square? Yeah, it's 12, or 12 is the square root. And so this is going to become w plus 12, w minus 12. Would you please talk to the person closest to you? What's t squared minus 25 going to turn out to be? Let's see, Finn, what's it going to be?
It's gonna be t minus 5 times the quantity of t plus 5.
Great. T minus 5, t plus 5. And then the last one, this one adds a little bit more. You could use AC grouping or not. That's perfect square, 4. And that's perfect square because square root of 49 is 7. It's a whole number. Would you please talk to the person closest to you? What's the factored form of this going to be? How about Pierre? What do you got?
7 times 2t minus 7.
Yep. So we're just taking the square roots of those and then putting in that form a plus c, a minus c. Looking at these, right now they are not all perfect squares, but if we take out a GCF, maybe they will be. So quickly tell the person closest to you what's the GCF of the first one.
6.
Yes, okay, heard it. 6. So we'll take that out. We get 4g squared minus 1. Okay, is 4 a perfect square? Is 1? Yes. So this is difference of perfect squares. And we are going to then split this up into have to be 2g plus 1 and 2g minus 1. If you're doubtful of yourself, multiply it out and check your work. please make sure that you are getting these done.
Like, that was actually
This is a perfect square trinomial because the first and last terms are perfect squares. 10 times 10 is 100. 11 times 11 is 121. The middle term should be 2 times 10 times 11 then, is it? Yes. Okay, so we're good. This one is a little bit different whenever those gentlemen are ready. This one's a little bit different because you see a minus sign. And so we're still going to do, it's asking for the side length of the square, so it's got to be the same thing twice. So it's still going to be a binomial squared. The first one would have to be, the square root of 100r squared is 10r. What's the square root of 121? 11. But this one, what do you think has to go in the middle? Minus a negative. Because that b term is negative. But it is still a perfect square trinomial. You could multiply this out and check and make sure it's the same thing. So I would like you to try that one that I just circled in green. 9a squared minus 12a plus 4. And the last one I want you to do is 9x squared plus 16.